Hey guys, Beans Brother here. Today we'll be talking about sticky stuff, specifically tape. Now, we're gonna go ahead and start out with our intro. We have a segmented tapes instead of individual of like one single point charge of tape, unlike the previous lab, and we're gonna do new measurements, data, and assumptions based off of that. We're gonna hop then into Glowscript and then do our final conclusions from there. So again, just to reiterate, we're treating this long piece of tape into several little segments of that tape instead of like one single point charge in the center locus of that tape. Now, we're going to go ahead and assume the following things: Newton's second and third laws for things like gravity, Coulomb's law for, well, calculating the charge on an electron, and superposition, which is the usage of several point charges to model an E field. Now, the result is that of 100 segments, we get about 1.962 times 10 to the negative third coulombs of electric charge. For some assumptions, we could go ahead and assume that we're going to ignore air resistance on the moving object since we're not going too terribly fast. It's not windy inside, or hopefully it wasn't. Now we're also going to treat each segment as a point charge as well, so 100 total segments, 100 point charges, and assume that each U-tape that you made had about the same amount of charge evenly distributed amongst it. So, you know, that goes back into you can't create or destroy charges. So, like, when you rip them off, if this one has charge, then it gotta come from that other piece that you ripped off charge. So, lab data from, just a quick recap of lab 1, we used 0.2 meters. If there was 1 gram per meter, then you have 0.0002 kilograms. And if you have 0.033 meters of average distance between that floating tape, then that means that you could, well, you're going to see later on. Here we also have force of gravity, which is just mass times gravity, 1.963 times 10 to the negative third newtons, and assuming that, again, using Newton's laws, you could just say that that magnitude of gravity is the same thing as force electric, which is 1.963 times 10 to the negative third as well in newtons. Now it's time for some code. Alright guys, this video is short, let's go ahead and keep it short. Here's constants, here's a definition of E field, here's a definition of all the line charges with appendices for things like the miniature Q's and M's for charge and mass respectively. This will be used later on for our segmented charge. Again guys, superposition, we're going to take a summation of all these. Now, with that information, let's go ahead and hop straight into the main important meat and potatoes of this code. For each little small charge in this top tape over here, I want you to take superposition principles and basically return back the summation of each of these and represent it through some pretty cool arrows. Orange will be electric field summation from superposition, and yellow will be the mass and gravity. Now, when we go ahead and run this program, we're going to go ahead and see that we have these purple arrows over here to represent each of the individual E fields emanating from that red tape that we were talking about earlier from that line appendice. The orange charge represents the E field summation, and the yellow charge represents the gravitational force enacting on that tape as well. Here we see that 1.962, the electric force, is equivalent to the gravitational force. And this is only because we find that the Q, just the Q charge that we would determine experimentally was determined in the beginning. If you were to use the old lab value, say that was like 1.4 times 10 to the negative 8, for example, then you would see that it would be a good bit off. So let's hop right into the conclusions off that high note. Alright guys, so let's go ahead and go through our final conclusions. What if you model these tapes as a single point charge, like in the previous lab, compare it, blah, blah, blah. Now, here's what's going to happen. You're going to have 1.54 times 10 to the negative 8 coulombs for original, and in the new one, you have a 2.924 times 10 to the negative 8 as a new coulomb charge. So, let's go ahead and lead into that as to why do these calculations differ, and that leads into the second question. And the difference is due to your calculations methods. In the first time that you had with the original in lab 1, you assumed that it was like a single little charge, like one single axis, one single difference, everything modeled based off of that. But now that we have a more literal assumption where we assume that charges are evenly distributed across this 100 segment tape charge, well, now we have more of a realistic model, since we assume that charges could be distributed along each of these segments. And so that leads us to believe that this 100 segment charge is more accurate, and thus concludes our conclusion on why not only are they more different, but why our new calculations in lab 2 are perhaps more accurate, or theoretically at least. Right, that's all for today. Beans Brother out.